All right, welcome everyone. Let's get right into it. We're going to break down your final assignment for SWE 6204 Machine Learning. Think of this as your complete guide to building a portfolio that really nails every single learning outcome. Okay, let's start with a big one, 100%. Yeah, you heard that right. This single 3,000 word portfolio is worth your entire grade for this module. No exams, no other coursework. It's all about this one comprehensive piece of work. Now, I know that sounds like a lot of pressure, but seriously, don't sweat it. A top grade is absolutely within your reach. We've put together a clear path for you, a roadmap, to guide you through every single part of this so you can shoot for that grade A. So, here's the plan. We'll look at how the assignment is structured, then we'll dive deep into the two main tasks, the practical project and the theory questions. After that, we'll get into the good stuff, what it takes to get a grade A. And finally, we'll run through a quick submission checklist. All right, let's get started. First things first, you've got to understand how this whole thing is put together. Your portfolio is split into two main tasks, and knowing where the marks are is, well, it's everything. And here's the breakdown. Take a good look at this, because it's important. Your practical project, that's task 2, is the real heavyweight here, worth a massive 60 marks. The theory part, task 1, makes up the other 40. Right away, that should tell you where you need to be spending most of your time and energy. So you can see it's really testing two different sides of your skills. Task 1 is all about the knowing. Do you get the concepts, the principles, the ethics? It's the what and why. But task 2, that's all about the doing. It's where you roll up your sleeves and actually apply all that knowledge to a real world problem. Okay, so let's zoom in on that bigger piece of the pie, the practical project. The scenario here is a classic, something you definitely see out in the real world. You're going to be building a model to predict house prices. And the good news is it's laid out for you in 4 really clear stages. Think of this not just as a suggestion, but as your actual blueprint for success. If you follow these steps one by one, you'll be on the right track to scoop up all 60 of those marks. All right, step 1, your first 10 marks are all about getting the basics right. Can you load the data set? Can you check it out? See what's inside? And, this is a big one, can you create some really meaningful graphs? The assignment specifically asks you to visualize things like size and location against the price, so make sure those plots are super clear and tell a story. Now we're at the core of the project. This is where 30 marks are up for grabs. You're going to split the data, pick a model, train it, and then evaluate how well it did. And please, don't just list the numbers for your metrics. You have to explain what they mean. What does that R-squared value actually tell you about how good your model is at predicting house prices? Okay, so you've built a model, great. But to get those top marks, you need to show you can make it even better. This is where you level up and use pro techniques like grid search to fine-tune it. The key here is to document everything. Show what you did and, with actual numbers, prove that your changes made the model perform better. And finally, step 4 is where you bring it all home. For these last 10 marks, you're basically telling the story of your project. What was the goal? What steps did you take? How did it turn out? And really importantly, be honest about any roadblocks you hit and what you learned along the way. That reflection piece is a huge part of what we're looking for. Okay, let's switch gears. We've talked about the practical project, now let's tackle the theory section. This is your chance to prove that you really understand the why behind everything you just did in the practical part. So question 1 gives you 4 different scenarios. Your job is to figure out if each one is supervised, unsupervised, or reinforcement learning. But listen, just slapping a label on it won't cut it. The real marks are in your explanation. You have to explain why it's the right fit. What was it about the problem that pointed you in that direction? Next up, you got to be precise. You'll be asked to explain the difference between k-means and k-nearest neighbors. They sound similar, I know, but they are totally different things, so be really clear. You'll also need to break down the whole concept of overfitting in detail. And when you're talking about overfitting, don't just give a textbook definition. Explain it like this. It's when your model gets too smart on the training data. It's like it memorized the answers to the test instead of learning the subject. Tell us why that's a huge problem, because it'll fail miserably on new data, and maybe even mention a way or two to prevent it. That shows you really get it. The last theory question is a big one for critical thinking. You've got this table to fill out about the challenges and risks of AI, and we're not looking for vague, generic answers here. We need you to come up with solid, concrete examples for big issues like bias in algorithms, or who's to blame when an AI makes a mistake that causes real harm. Okay, So now you know what you have to do. The next question is, how do you do it so well that you get a grade A? How do you push past that 70% mark? Well, let's pull back the curtain and look at the marking rubric, because all the secrets are right there. Look for these words in the rubric: exceptional and critical. Those are your magic words for a top grade. See, it's not enough to just go through the motions and describe what you did. To get a grade A, you need to analyze, to evaluate, to really dig deep and offer some insightful commentary. Just look at the language difference here. A C grade uses words like adequate or competent. It's fine. But a grade A uses words like exceptional, critical, and comprehensive. That's the gap you're trying to cross. It's the difference between just completing the assignment and truly mastering the material. So here's the takeaway. Make every single thing you do connect back to that rubric. When it says exceptional understanding, that means don't just use a model, justify why you picked it over other options. When it says comprehensive evaluation, don't just state your R-squared value, interpret what it really means for predicting house prices. And little things matter. Professional presentation is code for comment your Python code properly. All right, we're on the home stretch. Before you even think about hitting that submit button, let's go over a few final checks. Honestly, these are the little things that separate a good portfolio from a great one, and they can save you from losing some really easy marks. Treat this like your final pre-flight checklist. Word count, are you within the limit? Referencing, have you got your sources in there using the Harvard style? Formatting, are the basics like page numbers and your student ID in place? And this one is huge. Have you followed the rule about no generative AI tools? I'm serious, that is an absolute must. And I want to leave you with one final thought. Remember that this stuff really matters. This isn't just a classroom project. Think about it. What happens in the real world if your model consistently undervalues homes in a certain neighborhood? That could have huge negative impacts on people's lives. Thinking about those ethical implications, well, that's what separates a good software engineer from a great one. Good luck, you've got this.